Algebra 2, target 5. I can find and interpret in a context the vertex of a parabola. The last couple days we've been graphing parabolas, and early on in the process we've been finding our axis of symmetry and using that to find our vertex. We're going to use the vertex today and see what does it mean in certain situations. So basically the main idea we're going to be looking at today is how do we tell if our vertex is a maximum or a minimum? Right here we have a parabola that opens up like a cup. In this case, because it opens up, we have a lowest point. So our vertex in this case will be a minimum. And you can tell it's a minimum because it opens up. You can also tell because A is positive. A is positive means open up, opens up has a minimum. So we can go straight from when A is positive, our parabola has a minimum value. And conversely, when A is negative, it opens down, our parabola has a maximum value. So all quadratics where A is positive have a minimum, and all quadratics where A is negative have a maximum. So let's look at an example. We have a function, 3x squared minus 18x plus 20. Tell whether it has a minimum or maximum, and then find the minimum or maximum. All right, so let's answer the first question first. Does it have a minimum or maximum? Look at our A value. Our A value is 3. Since A is positive, it opens up, and a cup has a bottom. So this one has a minimum value because it is opening up. All right, then we want to go and find it. Now, since this is in standard form, we can find our axis of symmetry by using the equation x equals negative b over 2a. b is negative 18, so a negative 18 will be 18. 2 times a is 2 times 3. 2 times 3 is 6. So our axis of symmetry is at x equals 3. To find the y-coordinate of vertex, we're going to plug that in. We're going to do 3 times 3 squared minus 18 times 3 plus 20. 3 times 3 squared, that's 27. Minus 18 times 3, that's 54 plus 20. Right? This is negative 27 plus 20. So y equals negative 7. So our vertex is at 3, negative 7. So what that means is our minimum value, the minimum value of negative 7, happens at x equals 3. Right? So the y value is our minimum or maximum, and where it happens is our x value. All right? Let's quickly review. How do you find your vertex? We should be able to find your vertex in any form, standard form, vertex form, or intercept form. For standard form, we're going to use our equation negative b over 2a, like we saw in the last example. Once you have x value, you're going to substitute x coordinate into the equation and simplify, aka you know your plug and chug. For vertex form, it's just look at it and you can tell. There's h, there's k. You shift left to right, you shift up or down. Your vertex form, you can just pull it out. That's why we call it vertex form. And then for intercept form, you look and you can see your intercepts. And your axis of symmetry, your x-coordinate of your vertex, it's the balance point of your intercepts. So basically, you go right in the middle. You average it. And like standard form, once you know x, plug and chug, and you can find y. All right, so let's look at some applications, some context problems. A go-kart track has about 380 racers per week and charges each racer $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per week. How can the owner maximize revenue? So we need to start by writing an equation. I'm going to write my equation based on how much he lowers his prices. So that's going to be my x. So my x value is going to be how much my prices is lower, and I'm looking for revenue, so that's going to be R. Now revenue, or I'm going to say R of x, my revenue based on how much he's lowered prices. Revenue is number of people times your cost. Now in this case, he's saying his number of people is going to be 380 plus however much he gains by lowering his prices. He's estimating he's going to have 380 plus 20 more people for every dollar he lowers his prices. And his cost will be $20 or $35 minus whatever he lowers his prices by. So there's our equation. Now we need to get it into a form we can work with. We have three forms: standard form, intercept form, and vertex form. This one, you could make an argument for intercept form or standard form. I'm going to go to standard form. So I'm going to FOIL it out or box it out. You choose which method works best for you. I'm going to multiply 380 times plus 20x times 35 minus x. 380 times 35 is 13,300 plus 20x times 35 is 700x. 380 times negative x, and then negative 20x squared. We will combine like terms. We got negative 20x squared plus 320x plus 13,300. So that's our standard form. And now we want to go through and figure out where the max is. All right, we will, since it's in standard form, use negative b over 2a. Okay, b is 320, so negative 320. A is negative 20, so 2 times negative 20 is negative 40. Negative 320 over negative 40 will cancel our negatives, cancel our zeros. X equals 8. So when he lowers his prices $8, he'll get his maximum revenue. And to find his maximum revenue, we'll plug in 8. Revenue, when he lowers his prices $8, will be negative 20 times 8 squared plus 320 times 8 plus 13,300. His maximum weekly revenue will be $14,580 when he lowers his prices by $8, or 35 minus $27. All right, let's look at another example. The path of a place-kicked football in this example should look familiar to you. Can be modeled by the function negative 0.026x times x minus 46. X is horizontal distance and y is vertical distance, or corresponding height. How far is the football kicked? Well, if you take a look, we have this in intercept form. We got the 2 multiplied x's. This one doesn't look quite like you have it before, because usually it's x minus something and x minus something. Well, here it's just x minus 0. I'll write it in so you can kind of see it before. How far is the football kicked? Well, it starts here. That's where the x minus 0 comes from. And it lands here. That's where the x minus 46 comes from. So we can see if it goes from 0 to 46, the football is kicked 46 yards. Now, how high is it kicked? Right? We know it has a maximum height because A is negative. Right? So what do? We find our axes of symmetry by averaging those. 0 and 46 is 23. So somewhere here at 23 yards from the spot where it's kicked, it's going to max out. And we'll find that value by plugging in 23. So y equals negative 0.026 times 23 times 23 minus 46. Plug that in and simplify. And we can see that that football reaches a height of 13.754 yards. So this is the maximum height, and this is where it happens. That's an important distinction. What is the max and where it happens? Right? So in review, the vertex represents either the maximum or minimum of the function, of the quadratic function to be more precise. You can tell if it's a max or a min by looking at your a value. If a is negative, you have a maximum. If a is negative, if a is positive, you have a minimum. And then you find that by finding your vertex.